There's a lot of trends actually happening around Java. The two most prevalent to do with the expansive cost of cloud and the fact that proliferation of AI is driving far more infrastructure requirements on the back end. Applications like expansion in Kafka, HBase, Elasticsearch, all of these technologies sit behind the front-end AI technology, but they're really the mainstay of what brings it all together. And so as AI grows and proliferates, so too does the requirement and the expansion of these applications. And these applications, the real power, they all run on Java. So with that, now you need more compute. You need more compute to deliver the AI. And so how do you deliver more compute whilst keep your costs low, particularly if you're in the cloud? So the other big trend is replacing standard OpenJDK with high performance Java, faster Java. That Java speeds up the application. With that performance improvement, you can run the same application with less compute. And there are the real savings. So we're seeing a big trend in savings in cloud cost optimization in that area. I think it's important to understand AI in its entirety. There's the application that we interface with. And there's the application where we see the AI, we see the output of the AI technology. And yes, a lot of those are written in Python. But the real power behind AI is all of the applications that sit behind it. And all those applications that make AI possible, they're all written on Java. So Java is actually becoming the fastest growth. We recently did a survey, the state of Java, from 2,000 respondents. And of those respondents, we saw a significant growth of Java for programming AI language. So it's those applications in particular where the huge growth, the huge expansion is. That's where we're seeing the proliferation of Java as a result of AI. And all those applications, far larger environment than the actual front-end application that might be written in Python. So AI is driving huge Java adoption, mainly on all of the applications that make it possible. AI or no AI, cloud budgets are a big problem for customers and have been for a while. There are a couple of ways in which you can deal with it, right? The first is you can look at your usage, and this is one of the things that the cloud providers are very good at, is helping customers understand where they're reusing compute and where they've got excess compute and they don't necessarily need it. But that only gets you so far. The smartest customers that we're working with, the customers that are really looking at ways to reduce their cloud costs, they're re-architecting their stack. What I mean is that they're looking at the Java layer and they're saying, you know what? Why run a standard OpenJDK? What if I can get a faster Java sitting inside there? That equates to a faster application performance sitting above. And if I can derive faster application performance, then I have a choice. I can transfer that application performance to my customers if I want to, but more importantly, I can then use that performance improvement and reduce the amount of compute to deliver the same level of service. And if I reduce the compute, that's where I really get savings from my cloud providers. And whether it's Google, Azure, AliCloud or AWS, makes no difference. By replacing the Java, speeding up the application means less compute to deliver the same performance, and that translates to massive savings.